Hello everyone, I am Gowtham. I am here to explain about centrifugation. Centrifugation. Centrifugation is a technique which involves the application of centrifugal force to separate particles from a solution according to their size, shape, density, viscosity of the medium, and rotor speed. Not only in this process used to separate two miscible substances, but also to analyze the hydrodynamic properties of macromolecules. More dense components of the mixture migrate away from the axis of the centrifuge, while the less dense components of the mixture migrate towards the axis. Chemists and biologists may increase the effective gravitational force on a test tube so as to more rapidly and completely cause the precipitate to gather at the bottom of the tube. The remaining solution may be discarded with the pipette. In centrifugation, the feed is added to the spinning bowl from the bottom. Sedimentation of the particles occurs in a centrifugal field. The flow is upwards in a particular rate, which determines the residence time in device. Separation happens if the sedimentation velocity is high enough for a particle to reach the side of the bowl within the residence time. Large particles have high settling velocities than smaller particles. Both large and small or still particles have small Reynolds number and obey Stokes law. It's a general idea of separation of milk into skimmed milk, and the cream is done with the centrifuge. Small pictorial representation of the centrifugation process. Centrifugal motion. Centrifugal acceleration is equal to r into omega square, where omega is the angular velocity in radius and r is the radius of rotation. The centrifugal force is calculated by mr omega square, where m is the mass of particle. Here we compare the gravitational force and centrifugal force. The acceleration is constant in gravitational force. The acceleration increases with the r and omega in centrifugal force. The direction towards this earth and is away from the axis of rotation. Formula denoted for the gravitational force and formula for the centrifugal force. Here we see the sigma factor of the centrifugation. And next we are going to see about bowl centrifugation. The principle. A solid bowl centrifuge is a type of centrifuge that uses the principle of sedimentation. Solid bowl centrifuges are widely used in various industrial applications such as wastewater treatment, coal manufacturing, and polymer manufacturing. One advantage of solid bowl centrifuges for industrial uses is the simplicity of installation compared to other types of centrifuges. Types of bowl centrifuge. There are three design types of bowl centrifuges: conical bowl centrifuge, cylindrical bowl centrifuge, and conical cylindrical bowl centrifuge. It's the combination of both. Solid bowl centrifuge based on shapes design. Conical solid bowl centrifuge. Among the three designs, initially, conical bowl was the most preferable design due to its maximum allowance of water removal and its excellent classifying ability. However, the design is less effective in achieving a high concentrate quality, which makes it poor clarifier. Cylindrical solid bowl centrifuge. Unlike conical bowl design, cylindrical bowl design does not allow maximum water removal and thus mainly produces wet cakes. In addition, it is also a less effective classifier. However, cylindrical bowl design is more effective in achieving a high centroid quality compared to the conical bowl design, which makes it better dewatering device compared to the conical bowl design. Conical cylinder solid bowl centrifuge. Conical cylinder bowl design was developed based on the conical and cylindrical bowl designs. This design is basically a combination of the best individual characteristics of the previous two designs and therefore is a more advanced design. This particular design allows efficient dewatering ability, effective clarification, and fairly good classification within one unit. It has the ability to change the control of the balance between the water removal and the centered quality by the adjustment of its spool's length depending on the required product. Thus, conical cylindrical bowl design is the most widely used in the industry today. The typical conical cylinder solid bowl centrifuge design contains a rotating bowl unit connected to a conveyor with a gear system. The gear system allows the rotating bowl and the conveyor to rotate at different speeds but in the same direction. Commonly, the conveyor operates at the speed between 1900 and to 2400 rotation per minute, while the bowl unit operates at 100 rotation per minute higher. Sigma factor of bowl centrifuge. This equation determines the Sigma factor of Bose centrifuge. The disk stack centrifuge. This centrifuge is used to separate the higher settling particle which has more density. Benefits of disk. The disk splits the stream into a large number of very thin layers, thereby improving separation. Solid flow downwards on the bottom face of the disk. Liquid flows upwards on the top face of the disk. Sigma factor of the disk stack centrifuge. Facts. What is the capacity of the following disk stack centrifuge? Number of disks equal to 400. Space between disks is 0.01 meter. Inner radius is equal to 0.05 meter. Outer radius is equal to 0.20 meter. Half vertical angle is 45 degree and rotational speed is equal to 4500 rpm. Decanter centrifuge. This is the pictorial representation of decanter. Types of decanter centrifuge. There are three types: vertical decanter centrifuge, horizontal decanter centrifuge, conveyor centrifuge. Principle. The theory of gravitational separation is the principle behind the decanter centrifuge. Example. Fill a jar with a mixture of mud and water. After some time, gravity will cause the mud to settle down to the base of the glass. Therefore, we will get a clear separation between the mud and water afterwards. Working principle. Step 1. The mixture is inserted into the centrifuge through a connecting pipe and onto a conveyor. Step 2. The conveyor uses the slurry mixture through a nozzle into the bowl area. Step 3. The bowl rotates at a high speed to induce gravitational force. Step 4. High speed rotation separates the solid materials from the liquid in a matter of seconds. Step 5. The conveyor delivers the solid materials upwards where it is discharged through a nozzle. Step 6. With the solid material removed, the purified liquid is released from a separate outlet. Now we are going to see about the ultracentrifugation and its types. Ultracentrifugation. Ultracentrifugation is a rapid spinning imposes a high centrifugal force on suspended particles or even molecules in solution and causes separation of such matters on the basis of difference in weight. Its rotational speed is up to 1,50,000 rpm. It is creating a centrifugal force up to 90,000 grams. The schematic representation of ultracentrifugation. And this figure is a model of Beckmann ultracentrifugation. Types of ultracentrifuge. There are two types of ultracentrifuge: analytical ultracentrifugation and preparative ultracentrifugation. Analytical ultracentrifugation. The aim of the analytical centrifuge is used to study the molecular interaction between macromolecules or to analyze properties of sedimenting particles such as their apparent molecular weight. Preparative ultracentrifugation. The aim of the preparative ultracentrifugation to isolate and purify specific particles such as subcellular organelles. Types of analytical ultracentrifugation. There are two types of analytical ultracentrifugation: sedimentation velocity experiment, sedimentation equilibrium experiment. The aim of sedimentation velocity experiment is to interrupt the entire time course of sedimentation and report on shape and the molar mass of the dissolved macromolecules as well as their size distribution. Sedimentation equilibrium experiments are only concerned only with the final steady state of the experiment, where sedimentation is balanced by diffusion opposing the concentration gradients, resulting in a time-independent concentration profile. Preparative ultracentrifugation. It is classified into two types: differential ultracentrifugation and density gradient ultracentrifugation. Differential ultracentrifugation is a common procedure in microbiology and cytology used to separate certain organelles from whole cell for further analysis of specific parts of cells. Based on the density differences, there are two different types of density gradient ultracentrifugation: zonal or rate or isopenic. Zonal or rate ultracentrifugation. Mixture to be separated is laid on the top of the gradient, provides gravitational stability as different species. Move down tubes at different states. Isopycnic centrifugation. Isopycnic means of the same density. Molecules separated on equilibrium position. Each molecule floats or sinks to the position where density. This is the example of a scheme to isolate cellular organelles using differential centrifugation. Various organelles are separated from one another. The sample is centrifuged at the progressively in high forces. This is the example of density gradient centrifuge. A sample is laid on the top of the performed density gradient, and in tube 2, during the centrifugation, samples component separates to discrete bands as they move through a gradient. Functions of ultracentrifuge. Analytical ultracentrifuge use small samples such as 1 ml. In this, optical system to analyze progress of molecules is built in. Uses relatively pure sample. Beckman model is used as an example for this centrifuge. Preparatory ultracentrifuge. Larger samples are used in preparatory ultracentrifuge. No optical readout collection fractions and analyze them after run. Generally used to separate organelles and molecules. Most centrifugation work done using preparatory centrifuges. Thanks for watching this video. Thank you all.